So have you ever found yourself just staring at your computer screen, suddenly realizing you've copy-pasted the exact same block of code for like the 5th time today? You know the drill. You tweak one tiny variable, paste it again, and before you know it, what started as a simple, elegant script has mutated into this massive, unreadable wall of spaghetti code. Well, if that sounds even remotely familiar, you are in exactly the right place. Welcome to this explainer where we are going to completely eliminate that frustration for good.
Today, we're taking a fresh look at one of the absolute fundamental building blocks in software development, C functions. But look, we are not just going to sit here reading through dry programming theory. No way. Instead, we're going to use a super intuitive concept to break this all down into a really elegant framework. We're calling it the factory machine metaphor. By the end of this explainer, you won't just understand functions, you'll literally start seeing your code as a highly efficient automated assembly line.
And hey, a quick shout out before we get our hands dirty. The foundational concepts and the really brilliant structured logic we're exploring today are derived directly from the C programming guide by NgahTech Group. Their breakdown is just fantastic, and it really provides the perfect blueprint for our whole visual journey today.
Okay, let's lay out our factory floor plan for today. First, meet the function machine. Second, anatomy of a function. Third, the 4 function types. Fourth, data scope and pointers, and finally, recursion and the main. Let's get to work.
Section 1. Meet the function machine. So, what exactly is a function at its core? Just look at the stark contrast when you organize your logic. Think about the absolute chaos of writing a program without functions. Let's say you need to add 2 numbers together multiple times. Without a function, you're manually writing out that exact addition logic every single time you need it. It gets completely cluttered, it's a nightmare to read, and worse, if you make one typo, you have to go track it down and fix it in 10 different places. But when you wrap that logic into a single clean block, say an add function, it's a total game changer. It becomes perfectly reusable. You just call add whenever you need it. It makes debugging and maintaining your code endlessly easier.
Which brings us to the absolute golden rule of today's explainer, pulled right from our source material. Think of a function like a machine. You give it input, it performs a task, and it may give you an output. I really want you to hold on to that image. Visualize a literal machine sitting on a factory floor. You feed raw materials into one end, those are your inputs, right? The machine whirs to life, doing whatever it's designed to do, stamping, cutting, combining, that's the task, and finally, a finished product pops out the other side. That is your output. That is exactly what your code is doing when you format it as a function.
Section 2. Anatomy of a function. Let's look under the hood and actually build this machine.
Now, before you can build any machine on a factory floor, you got to submit a blueprint, right? Well, in C programming, that blueprint is called the function prototype, or declaration. It sits right at the top of your file and essentially taps the compiler on the shoulder to say, hey, just a heads up, later on, I'm going to use a machine with this specific name, it accepts these exact types of inputs, and it's going to spit out this specific type of output. This preps the compiler so it doesn't totally freak out when it encounters your custom machine later in the script.
When it comes down to the actual construction, what we call the function definition, there are 4 absolutely crucial parts. First up, the return type. This tells C what kind of product the machine makes. Is it an integer, a character? Next is the function name. This is simply what you call your machine, like add or calculate. Following that, we have the parameters. You can think of parameters as the input tray. It's the variables the function needs to receive to do its job. And finally, the function body. Wrapped tightly in those curly braces, this is the internal engine. It's where the actual line-by-line instructions live that tell the machine exactly what to do with the raw materials.
But wait a second. What if your machine doesn't actually produce a new item? What if its only job is to, stamp a welcome message on a box as it rolls down the conveyor belt? It definitely does a job, but it doesn't hand a brand new piece of data back to you. Well, for that exact scenario, C gives us the void keyword. If you set your return type to void, you're explicitly telling the compiler, listen, this function is going to perform a task, but expect absolutely nothing in return. Our source uses a really perfect example for this, a welcome function that just prints text to the screen. It spins up, prints the message, and then quietly powers down.
Section 3. The 4 function types. Let's see the different models available for our assembly line.
Now, what's really fascinating here is how neatly all our options categorize into 4 distinct combinations, just based on inputs and outputs. Type 1 has no parameters and no return value. It takes 0 raw materials and gives back 0 product. It just triggers a standalone action, kind of like that void welcome example we just talked about. Type 2 has parameters, but still no return value. You feed it data, it processes it, maybe prints out a result, but it hands nothing back to the main program. Type 3 is the reverse. It has no parameters, but it does return a value. Think of a random number generator. It needs no input from you, but it gives you a fresh number every single time. And then there's Type 4. This is the most common one. It has both parameters and a return value. This is your classic calculator function. You pass it two numbers, it crunches them, and hands you back the sum.
Section 4. Data scope and pointers. This is absolutely crucial for managing how data moves around our factory.
The very first thing you need to wrap your head around here is the concept of local variables. When you create a variable inside a function body, it belongs strictly to that function. It is entirely walled off from the rest of the factory. If your test function creates a variable named x, the rest of your program has absolutely zero idea that x even exists. Basically, what happens in the machine stays in the machine. And honestly, this is a brilliant feature. It prevents different parts of your code from accidentally crashing into each other and corrupting each other's data.
Because data is so heavily walled off, we have two different ways to handle modifications. Normally, C is, well, it's kinda overprotective. It defaults to passing by value. It essentially makes a photocopy of your data and passes that into the machine, leaving your original variable completely untouched. But what if you actually want the machine to alter the original data? Actually, scratch the photocopy idea. If you want to change the original, you have to pass by address using pointers. Instead of giving the machine a copy, you give it the exact physical location on the factory floor where that variable lives. By using pointers, the function reaches out to that specific address and directly updates the original data. Pretty powerful, right?
We are in the home stretch now. Section 5, recursion and the main. Let's talk about the master switch and loops. You know, we've talked so much about building all these custom machines. It's super easy to forget that the entire factory building is actually a machine itself. In C, the main function is the absolute starting point of your program. Think of it as the master power switch. Every single C program has to have a main function, because when you run your code, this is literally the very first block of instructions the computer executes. From main, all your other custom factory machines get called into action.
And then there is this mind-bending, incredibly powerful concept known as recursion. Recursion happens when a function actually calls itself from within its own body. Just imagine a machine that, in order to solve a really huge problem, builds a slightly smaller version of itself, hands off part of the work, and waits for the result. Our source guide uses the perfect example for this, calculating a factorial, like 5 factorial, which is 5 times 4 times 3 times 2 times 1. A recursive factorial function just takes the number 5 and multiplies it by calling itself again to calculate the factorial of 4, and so on, all the way down the line. It's a remarkably elegant way to write loops without using traditional looping commands.
All right, let's bring this all together. Section 6, the factory glossary. These are the essential terms you need to survive on the factory floor.
Understanding C functions really just comes down to speaking the language. I highly recommend taking a quick screenshot of this glossary right now. It's your ultimate cheat sheet. A function is the machine itself. The declaration tells the compiler the machine exists. The definition is the actual nuts and bolts code inside. A call is when you hit the start button to execute it. A parameter is the empty variable waiting for input. An argument is the actual tangible value you feed into it. The return value is your final finished product. Void just means it returns nothing, and recursion is the machine calling itself. Master these 9 terms, and for sure, you master C functions. Which leaves us with one final thought. We've seen exactly how transforming messy, repetitive logic into clean, automated machines makes your code readable, reusable, and just infinitely easier to maintain. You've got the blueprints now. You know the 4 types of machines you can build, and you understand how data safely moves through them all. So, take a hard look at the project you are working on right now. If you could build a machine to automate any part of your code today, what is the very first function you're going to write? Thanks so much for joining me on this explainer, and hey, happy coding.